Hello, I'm José Luis Martinez. I'm going to talk about how to build an SDK for Amazon Web Services, or about the initiative to build an entire SDK. And a bit about the lessons learned. If you're going to try to implement some type of caller for remote APIs, well, what patterns you can use to call other web services. At least you won't go through the pain that I had to go through. So a bit about me. I'm CTO of Capside. We architect, build, and manage platforms for our customers, and we're using AWS a lot. So historically, since we know a lot about AWS, we became training partners, and I personally have all the certifications for AWS and get real experience with real platforms running on AWS. And I've been writing Perl for 10 plus years by now, and the good thing is I'm still having fun with it and still learning. And a bit about AWS. Who knows AWS here? Who uses it? Okay. AWS, I like to say, is the paradigm of the cloud. Amazon Web Services is bringing cloud computing to everyone, and it's the most advanced cloud for now, as some analysts say, and I personally think so too. The thing is that it's not only computing. People know Amazon Web Services mostly for computing, and that's their EC2, their elastic compute cloud. An object storage, basically you store files, you throw files at it, and you don't need storage. Throw terabytes and delete it all, and only assume. Having problems?
Yes, there's someone else on the frequency.
Ah, okay. Don't worry. Okay. So, but it's not only about virtual machines and object storage. Those are only two services. There are 30 plus services in AWS. They offer queues as a service. SQS, simple queue service. If you need to put jobs on a queue, you just call an API and start pushing messages to it. And you really don't have to provision any machines, and you don't have to manage them. And lots of the services there are called regional services. They have high availability built into them. They're already available in 3 separate data centers. So if one data center goes out, you don't even know about it. You still you just push messages to your queue, and the queue is fully available. So it's interesting for building services in a highly scalable and reliable manner. And part of what I like about that is, or about AWS, is that everything is an API. And when I say everything, I see even support has an API. There's a service where you can send hard disks to Amazon. That's called via an API too. So they really have this everything is an API thing in their core. So I like to say that it's your wet dream, because you're all programmers. The bad news about Perl and AWS is AWS doesn't publish an official software development kit for Perl and all the services that you can consume from AWS. It has published for Ruby, for PHP, for Python. The Python one even started out as a community project, but they hired the guys and made it official. You have support for JavaScript, .NET, Java, but no Perl. The good news is that Perl has a big community behind it. It has the CPAN. So people have already started publishing ways to consume the different AWS services. So if you go to CPAN and type in AWS or Amazon, you'll find a lot of modules. The slightly bad news is that every module is from its, has been done by a different author. And that produces some inconsistencies. So you get method names, or basically for a service you have a lot of methods. Method names get called differently. Some do camel casing, some do all lowercase and underscores in a more Perlish fashion. And so depending on the classes you use or the modules you use, you have to be aware of that. And you also have to be aware of some arbitrary defaults. So the author just said, okay, my default is okay. You can consume services. The SQS service, for example, you can consume it in 3 locations in the United States or in Europe. So depending on the author of the module, he just selected the default that went good for him. So maybe you just instantiate a class and you're consuming a service in Europe because the author was European. And what you see is that AWS is innovating at a pace that really scares. So I think that by now, this year, they've had over 200 new features, and these types of new features mean API changes. And so the CPAN modules tend to fall not unmaintained, but they don't get the new features if the author is really not keeping a good track of it. And also there is not so popular services or not so known services that you can't call from Perl because no one has taken care and implementing them. So, but they are supported in the official SDKs. And one feature that's really great from AWS is if you're running code in AWS virtual machines, you can give those virtual machines credentials to call the APIs, and those credentials will be temporary and rotated as a best practice. The Perl modules don't support this, and we went through a couple of modules patching to support this type of behavior, but of course some authors are not responsive, some did incorporate stuff, but you're just banging yourself with lots of different code in different styles. And that role support is great, because when you want to call AWS's APIs, you need an access key and a secret key to identify yourself. And that access key and secret key has permissions attached to it. So it's great if you don't have to burn your credentials into your code or configuration files. If you're running in AWS's virtual machines, they can get temporary credentials for you. So security-wise, it's better to do it that way. So seeing this panorama, we thought, why not write an entire SDK for Perl? How hard can that be? Well, it's hard enough. It's not impossible, but the thing is that when you try to go for a big project, you can end up with one of these two. So let's take a look at the challenges and that we've been addressing, and a bit of how we've been solving that. The thing is that AWS, I've already told you, 30+ services. Some of those services have over 100 API calls, 100 methods. Each call has its parameters, so string, boolean, blah, 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 blah. And each call returns some type of objects. And doing this one time maybe would be a hard task, but it's even harder when they're constantly adding stuff. So one challenge is this type of, we have lots of services. So we need to start like classifying these services. We have to put them all in their places because they do have commonalities, and if we exploit these commonalities, we can, the project seems more feasible, no? So, for example, endpoints, there are services that are called regional. Regional services, you have to say in what region you want to consume that service. And there are global services, like the credential service that gives you your access key and your secret key. That's global. Your access key and secret key works all over for all the regions. So we have 6 global services, and all the rest have specific endpoints for specific regions. So when you want a virtual machine, an EC2 instance that we call them, you say, I want it in US East 1. And you have to call the API in US East 1. So also, of course, these guys have, they didn't do things right the first time. People and companies also evolve and learn from their mistakes. So the API calls, the way the web services behave is different. So basically we have 4 types of calling web services. We have one where you just use one URL. The service has one URL for each region. That's a different, it would be a different endpoint or a different domain name, but the URL, the thing after the slash is constant. So no problem there. You send the parameters, the actions that you want, you have to send them via query parameters. And then you receive the response in XML. And that's for 17 services. And then there are 3 special services where you still send the parameters in the query. Your response is XML again, but for each object you have a URI that changes for the object. So you have to take that into account. The green, yellow, and red is the implementation status of each type of service. By now, we've I've implemented 27 services. The sum of these still not implemented the RESTful services because, as you see, I wanted some quick wins, no, and I didn't go for the REST services that are a bit more complicated. And then there are services that one URL for each region, and you send the parameters in JSON, and you receive the responses in JSON too. Let's classify a bit more. The thing is that every, yeah?
Replace this again.
Got my channel back?
Yes.
Yes.
Okay. Go.
Okay, thank you. So, signatures. The thing is that with your access key and your secret key, these identify you. And they have their permissions attached to them. The thing is that for each type of web service, you sign your request with your access key and your secret key. Why aren't we using normal user and password? The thing is that your secret key never gets transmitted over the wire. You sign your request with your secret key, and that secret key never leaves your machine, and they validate the secret key as a shared secret between you and AWS, and when it gets to their endpoint, they validate that that you were the one that signed that request. So the thing is that signatures have evolved too. So there's some variability in signature calling. Let's see more. Even, well, you see V2. V2 is like the first one they had, and V4, this has been changing over time. They're migrating services over to the V4. But in between, you have like V3 HTTPS for S3, and CloudFront had a special signature too. So the way you take the access key and the secret key and construct that signature changes for each type of API too. Let's take another look at another challenge, the API versions. So not to break backward compatibility, they version their APIs. So when you're calling the EC2 service, you call EC2/2012, blah, 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 blah. And they promise that they won't break the backward compatibility, always that you attack that, that endpoint. So you have more than one live API that works. The thing is that if you want to do an SDK and have the new features, you have to change your API to be calling the ultimate version. So, like RDS, the relational database service, you basically say, I want a MySQL, and they will set up some virtual machines with MySQL running on it. Has 4 API versions. Wow. CloudFront 3, EC2 4. But the thing is that some SDKs do support the old versions. I decided why not just support the actual versions of always be on the latest version of the API. So the thing is that you're just seeing monthly changes. Now we support this, now we support that. Could pass this parameter to enable this new feature. It's hard to keep up with these guys. So we thought, let's start writing a bit. No, how will we do this? Because Of course, we were contributing patches to some CPAM modules, getting variable responses from that, but when we thought about doing an entire SDK, it was like, nah, crazy. Because we were thinking about handwriting classes, methods, all the parameters, and you've already seen that's a big task. So you would basically end up with this. So programmers are lazy, so we try to think of the best way to not have to type too much. So why not parse the documentation? Took a look up at the documentation. It seems like it's parsable, but it's not. Lots of different, there's lots of different small tweaks in different documentation. So, and even in the vast majority is in HTML, but there is some in PDF. So, so parsing docs is like, nah, too hard. And another thing is that call AWS and just say, do you have specs for this? No. No, the specs are basically not published. So we thought, whoa, why? They do publish the spec in some type of way. Why don't we get an SDK, an official SDK from another language, and introspect their objects, their parameters, and generate the Perl classes for them? And that seemed like a good idea. No? Let's try to let's start fiddling around with their SDKs. No, and this was like the aha moment. We can introspect. So let's get the Python SDK or the PHP SDK and take a look at their objects. And we found out that success. They had the same maintenance problems that we were going to face. That they're maintaining. They have teams that maintain every SDK, and these teams have to coordinate and get the new features out. So some of the SDK teams had already opted for what they call a data-driven SDK. They'll do big configuration files that specify what are the API calls, the parameters, how to validate them, and what are the objects returned. So we found the first one, the JavaScript SDK, and we were like, yes. But there wasn't sufficient information in them. So we had to start inventing lots of information. There wasn't class names, for example. But when we got a win, a very big win, we did like a proof of concept with the JavaScript SDK. We got to generate some classes, some working classes to call AWS's APIs, but we were seeing that we would have to fill in lots of information to really get all the services implemented. So looking at other SDKs, the Boto is the Python SDK, and the PHP, well, we found more suitable definitions for us. So this is the moment. No? So basically, to take a look at let's start writing classes, not writing, having Perl write the classes for us, and trying to do this in a maintainable way. So the thing is that I'm trying to be very, very, very lazy. Parameter validation, for example, the parameters that you will pass of a method call I really construct an object for the parameters and let Moose validate that the parameters are okay, if you're passing in strings or integers or blah, blah, blah. I know it's not that efficient, but we're trying to get things that work and trying to optimize later. So the thing is that every call has an associated object for its parameters. You slurp the parameters into a new. That Moose object gets created. If it has the correct parameters, it gets created okay. We now have a valid object representing the parameters for the call. And the thing is, that worked out okay. But you really can't, you really don't want the user to know that we're constructing a Moose object underneath to validate parameters, so we can change the implementation. So trying not to leak any implementation and just trying to, for the user, that would be you guys, the programmers, they have the same interface all the way. They just call a method with the parameters like a hash, and that's it. What we do in the background shouldn't be important to them. And the good thing is that using Moose with the meta object protocol, you can inspect those classes. So you can get their attributes and then inject them to an HTTP request, serialize them in the way that they should be. So we put our code to work, and the thing is separating tasks. You guys do this, you guys do that, and how do you do that? Well, it results that Moose has roles. You should probably know of roles by now, but it's a way of having a classing, popping some code into it. So the idea was that all functionality, don't generate code, just treat the classes that are generated by the definitions like a serialized representation of what has to be done. But the actual doing, what we do with an object and how we inject the parameters into the HTTP request, gets pulled in by roles. So if you have a role that can sign version 2 and a role that can sign version 4, and you have a role that can serialize in JSON, and the role that can deserialize the JSON, you just have to pop roles onto your classes, and magically things start working. So that makes it very, very easy to generate these service classes, or for each service we generate a class, and that class has methods, and those methods have parameters. So what we call service classes, there's an EC2, you instantiate an EC2 class for calling EC2 methods. And it's, the thing is that it makes it easy to generate these service classes because they really don't have any code, and you just attach roles to them. And also testing becomes easier too, because you can generate fake services and test that behavior without really calling the actual service. So we're using roles for deciding global endpoints versus regional endpoints, how to call, how to serialize those objects that were constructed to validate the parameters, get pushed into the callers, and the callers serialize arrays and data structures to something that later the API will understand. And it's not trivial because they support passing arrays with hashes in them to describe, like if you have various Ethernet cards on the instance, you pass in an array with various hashes in the middle. The thing is that HTTP doesn't support that type of stuff. Or passing things in parameters. So you have a very special way of converting your objects to HTTP compatible ways of passing parameters. So responses to get their own roles, and I have to thank all the CPAN authors which I've been robbing code from, just adapting it because, of course, there are already people that are calling APIs, just not the APIs that I want. So I can rob in a good open source manner the code for parsing the XML responses and the JSON responses, and for signatures too. And even I/O has its own role. So default role is to call web service with HTTP tiny, and that's good, but it blocks. And the guy came around and said, an Indian guy said, I want to do async I/O with this, and I said, let's try to fit that in. And since the I/O was a role, we got to plug in asynchronous calling into the SDK with almost no work. The thing is that his asynchronous calls, he wanted to call the APIs in a non-blocking manner, but for one thread, it was not important to block. The thing is that that thread would leave other threads to work too. So the thing is that we made a role for non-blocking I/O, but it returns synchronously, so you don't really have to change your code, and it's doing it with Mojo. So you can, in a Mojo thread, you just call the service and you receive the response. It looks like synchronously, but it's leaving time to other threads to do stuff. And we have another asynchronous caller that returns immediately, and then you have to set callbacks for your responses. We'll see that in a minute. So the thing is that we made a sort of class factory for, you really don't even instantiate your classes, the EC2 class directly. When you want to call a service, you say, give me a class for calling EC2. And that class gets dynamically attached all the roles that it needs. Those roles come from a configuration. And the thing is that if you want to go and test and not call the actual services, you say, okay, AWS, configure yourself so that the caller is a test caller. And instead of putting in the role that actually calls the services, it puts another role in, the test caller. And now, boom, you can test your classes. Welcome to the async world. You just say, oh, color, no, I want my module color. And you get a real class. When you call this, you get a dynamically constructed class with this configuration injected into it. So you can have in the same code, asynchronous calling code, synchronous calling code. You can just have classes of different types. And you can also go fully async. So we wrote another color type. I'm sorry because this is too small. No? But basically, the async color will let you call a method, this describe trails, and it returns immediately. And here we're doing a wait. And we can see this demoed. So normal CloudTrail, and sorry for the includes, the inline includes. The thing is, I'm trying to keep the code apart. The handwritten code is in lib, and the automatically generated code is in autolib. So just to keep things clean. And let's call a service called CloudTrail, and for each region, just call a function called describeTrails. So you'll see that one result for one region. I think Wi-Fi is not doing us justice here. That one went a bit better. You're seeing it's not the fastest thing in the world if you want to do lots of calls. So let's just stop that and go for the async CloudTrail caller. Boom, SDK loading, doing seven calls, boom. There you have the 7 responses. So, yes, the plan is working out. But I have to advert I have to give you back some of the lessons learned. First of all, to go quickly and to prototype quickly, I picked doing stuff with MoveX declare. It's not bad. The only bad thing about it is the error messages are horrible. And when I mean horrible is that I couldn't understand the vast majority of them. And I had to comment code sometimes to say, okay, now this works. Now let's start uncommented code to see where I did something wrong. So, then I think that it's Matt Trout has an implementation called Moops. And of course, that was my fault because MoveX declare has a big warning sign on it saying don't use it. But okay, I was prototyping and I wanted to go fast. So I thought, okay, we'll be able to change it to Moops. That's like MoveX declare, but does things in a saner way. And that didn't go well. When I changed from MoveX declare to Moops, things blew up. Couldn't get the thing working, so I finally said plain old Moose will do. Another thing, the namespace. You've seen a namespace called AWS. That's really not going to be the definitive namespace, and I'm trying to find the namespace. Because the thing is that started out thinking, let's call the namespace AWS, all uppercase. You go to CPAN, type in AWS in all uppercase, and that namespace is plagued with other authors' modules. So I saw a trick there. I saw the Ruby SDK guys did a trick for their version 2. They lowercase the W and the S, and since Ruby is case sensitive, it would load the correct SDK. And I thought, wow, we can do that in Perl. And I saw that Clinton Gormley from the Elasticsearch team that maintains the Elasticsearch API did the same trick. And I thought, let's go for it. And that's why you see in the presentation a uppercase WS. I have to thank Clinton enormously because he posted a blog post saying why that's a bad decision, because he got shot in the foot. And it's basically because when you go to Windows file system is not case insensitive. Things can blow up if you have, you'll start to overwrite other people's PMs. Oops. So I have to thank him enormously for not letting, for publishing that and not letting me release code that would break other people's machines. Another thing that that I learned the hard way is that enums, when they say this can return a list of values from the API, and you go and you say, okay, I'll validate that the API is returning me these series of values. Your code blows up one day because the API changes its behavior they add an element to the list, like a new instance type, a new set of RAM and CPU, and suddenly when a list comes with that instance type, your class blows up because it's validating and it says, I don't know the R3 8XL large. So the thing is that finally, I selected to just go for treat an enum as a string and not validate the response. Try to validate the calling. So if you call with an unknown instance type, you will get an error. But if the API returns something unexpected, well, it won't blow up the code. You will get that value. And that happened even in the documentation. Had a place where it said Windows with W in uppercase, and the API was returning the W in lowercase. I said, wow, this has to be failing in the other SDKs. No, it's not, because they're not validating their enums. They have, in the definition, they say, this will return this, this, and this, but they don't validate it. So with the returning data from APIs that can change quite a bit, take care that you don't overzealously validate what comes from that. And another thing that resulted quite usefully is having an abstract request object. I started doing an HTTP request object and putting things on that, and each role would configure the HTTP object as needed, and it was hard to coordinate all the roles. So finally, an abstract request that would represent my interests, not HTTP requests interests, would be pushed around the roles and finally marshaled into whatever the user agent needs. So that helped implement very rapidly the Mojo caller, because Mojo has a different-ish way of doing the API, the HTTP request. And of course, you still have open stuff, no? Let's say that the load time with MooseX declare was suboptimal. I'd say pain. It was a pain, especially with the big classes like the EC2 that has over 100 calls and like thousands of objects. Everyone is a Moose class. So every service, that's one class. Then every call has the object that validates the parameters, and so that's the number of calls. And every parameter has a class for complex objects. If it's a simple string, it's just a string. But if it's a block device mapping that has lots of attributes, well, we generate a class for that. And the EC2 is humongous, and it would take like 20 seconds to instance just to use EC2. So that was for MooseX declare, but for plain old Moose, it's better now, but it's still some seconds to load up. And if you just use all the classes, you will die waiting. So the thing is that classes will not be used all the time. So if you're just using a couple of services and you have and you don't care about start time by now, well, okay, it's usable. But the thing will be to try to generate classes on demand, because you don't have to pre-declare your classes in your code. You can tell Moose to create me a new class. It has these methods, these roles, and you can generate it at runtime. And maybe the thing is just having some configuration files, and when you say, give me an EC2 service class, generating only the classes that it needs, and as classes are needed, generate them dynamically, so you don't feel the impact of hundreds of classes that you won't use because maybe you're just calling 3-4 methods. Also, calling conventions, for now they're camel-cased because that's the way they are in the definition files. But that's not so Perlish, so there is some work to be done around generating more Perlish method calls. And that's expected to be some type of role or some type of configuration that you can say, no, now give me the SDK in the camel-cased flavor, and now give it to me in the Perlish flavor.
Can I have random case?
Sorry?
Can I have random case?
Sorry?
Can I have random case?
You can implement that if you like to. But please make it consistent between runs, because and of course the thing is that you get a service object and you have to say like delete queue and send it this queue, send it the ID of the queue. And the thing is to plug in some type of functionality that when you get a queue object back, you can call delete queue, it knows its ID, and it calls the service class saying delete queue, this queue ID for you. So you can treat the objects in a more object-oriented fashion. Yeah, I also want to add attribute traits, the Moose attribute traits. So when you treat lists and you do it in a more I'd say abstract fashion, and that would be good because then if we change implementations, we can conserve the behavior, and of course there's lots and lots more. And if you have ideas like random case, I would like that you contribute. Just fork your heart out. Get an AWS account. You have like a free tier where you can call where you can play around for free. And if you're using AWS and in a more production-like fashion, well, maybe you want to use an SDK that's a bit more consistent. And up to date. So that's it. I'll leave you that so you can fork around. And questions? I left you without. Was that boring?
No.
Okay, that's good. So, thank you.